Hey guys, welcome to Unit 7. Our unit is trigonometry and we are going to get started with lesson 1. I would want you to pause the video and try the do now. So the do now says the ray below is fixed to the x-axis. Create an angle from this ray that terminates in the third quadrant. Okay, so there are a few things that we need to kind of review real quick. First of all, anytime we talk about an angle, I'm going to sketch it here on the side, that your angle, if you have two rays, your angle is connected in between. We usually use a Greek letter theta to denote our angle, right? This side of the angle, I'm going to actually highlight it. This side is always, this is called the initial side. This is called the initial. And this one is called the terminal side. So what happens is your terminal side is always glued to the x-axis like it is glued here, right? And our angles, if they go in counterclockwise direction, they are positive. If they go in clockwise direction, they're negative. Going back to geometry. Remember in geometry you did that? Then your coordinate plane has 4 quadrants. You always start with the top right, which is the first quadrant. Again, you're going to go in clockwise direction. This is second quadrant. This is third quadrant. This is fourth quadrant. So my initial ray is always glued with the vertex being at the origin. That's your vertex here, right? So the vertex is at the origin always. And then your terminal ray, it's like moving. I can move it, and if it's telling me first quadrant, I'll end here. If it's telling me second quadrant, third, wherever it's telling me or how big that angle is, it will kind of, I'll end up there. Also remember, around the circle it's total of 360 degrees. So when I go around here, this is going to be what? A total of 360 degrees. So can I say this is 360 degrees? Also, since we started from here, this is 0 degrees. So I started 0, and then I'm going to go by what? Increments of 90, right? Because if it's a total of 360 and I have 4 equal half parts, so what would it each part be? Each would be a fourth of it, right? So this is 90, this is 180, this is 270 degrees, and that's 360 degrees. And we can keep going on and on and on. So these are a few things or prior knowledge that we needed to know before we started this unit. So again, anytime you're given an angle, unless it tells you a negative, that's when you're going to go in clockwise direction. Otherwise, it is assumed you're going in counterclockwise direction. So I'm going to quickly erase this, and then we're going to talk about the question that is being asked. So it says a ray below is fixed to the x-axis. So one of the ray is already given, right? So I want to create a ray that terminates. Terminates means basically ends in the third quadrant. So my angle would be in the third quadrant here. That's my, it could be anywhere. It wasn't being specific. So that is your angle, right? And as I said, we usually use what? Theta to denote our angle. You can use that. It didn't really say, so that is your angle. Okay, so that's basically it was for the do now. An angle in standard position. Keywords, we need to understand this, because the minute I say standard position means what? Standard position, that means that my initial ray is glued to the x-axis and I'm going in counterclockwise direction. If its vertex is located at the origin, right, we talked about it a little, and the initial side is on the positive x-axis, the other ray is called the terminal side. If the terminal side of an angle lies on the axis, so I'm going to show it up here. If my terminal side was this, what would be my angle? My angle is what? 90 degrees, right? So it could be 90, or if it's here, then it would be 180 degrees. On the axis, I'm on the axis, so these are the angles. 270, then what? 360. I wanted to do 0 also, and 0 degrees. I should have started with 0, right? So it is called quadrantal angle. So your quadrantal angles are your angles that are on the axis. So 0, 90, 180, 270, 360, and so on, right? So let's quickly again talk about a quadrantal angle. So we always start, if my initial and my terminal ray are both on the x-axis, so it'll be 0 degrees. Then going in counterclockwise direction, 90, 180, 270, and 360. And if you're ever confused, think about a clock. Let's say if I had a clock, up, which will be tough. Do you agree if this is the minute hand, or I'm starting at what, my 3 o'clock position? This is 12 on the clock, this is 3, this is 6, and this is 9. So I'm always starting at my 3 o'clock position, because sometimes you'll see questions being asked that you're starting at a 3 o'clock position and you're like, what is she talking, what is the question talking about? That's what it means, which we will address later, but I just want to bring this up again. That was when we labeled our quadrantal angles in counterclockwise direction. What if we want to go in clockwise direction? Then 0 will still be 0. 270 is same thing as negative 90. 180 is same as negative 180. 90 is same thing as negative 270. And 360 is same thing as negative 360, right? So either or, so you should be able to comfortable writing it both ways. The measure of an angle is positive when the rotation from the initial side to the terminal side is in the counterclockwise direction. If you guessed that, you were right. The measure of an angle is negative when the rotation from the initial side to the terminal side is in the clockwise direction. Okay, for each of the following angles given by the Greek letter theta, draw a rotation diagram. So all we're doing is we are sketching our terminal ray and our initial ray. We're going to start with our initial, and then of course we're going to do our terminal, right? So let's do that. So it's saying theta equals 145 degrees. Again, it's a good idea in the beginning, especially you want to mark up your quadrant. So 90, 180. Since it's positive, I'm going to go in clockwise, counterclockwise direction. 270 and 360. Okay, where is 145? 145 is going to be, your initial ray is always glued to the x-axis. So that's my initial ray, right? And 145 is in between 90 and 180. So my terminal ray would be here. And that is my angle theta. You can do the swipe or you can just write theta. That's fine. Negative 310. So I'm going to go and mark my angles negative. So means what? I'm going in clockwise direction. So 0, negative 90, negative 180, negative 270, and that's negative 360. So where is negative 310 going to be? It's going to be in the first quadrant. So my initial ray is still here, and my terminal ray is going to be in the first quadrant, but be very careful, right? This is negative 310. That is marked by theta. That's my angle theta. 460. So again, it's positive, so I'm going to go in counterclockwise. 90, 180, 270, 360. 460 is more than. So basically we're doing times table of 90. So 360, this would be what? 450, and this would be what? 540. I'm just going by increments of 90. If you're confused, you're just adding 90 each time. So 460 is what? In the second quadrant, right? So your initial ray again still is here, but your terminal ray ends in the second quadrant, right? So here, what did I do? I did go around a complete circle, and then I did more. So that's what your theta is. Negative 400 would be negative, so it'll be 0, negative 90, negative 180, negative 270, negative 360, negative what? 450, very good, and negative 540. So 400, negative 400 is in the fourth quadrant. So I'm going to go, my initial ray, as you see, is going to be here, and my terminal ray is going to be in the fourth quadrant because negative 400 is in between. It is in the fourth quadrant, right? So I'm going in clockwise direction, and that's my angle. Okay, and I'm going to label it theta. Please check out E and F, and this is what your picture should look like too. I just didn't put 360 degrees here. Okay, coterminal angles. So think about what does the prefix co means. Just like in co-workers are people who you work with. Coterminal also means the same thing, that share the same terminal side. So if two angles in standard position, again the keyword standard position, for most part in Algebra 2 you will have angles in standard position, meaning your one side or your initial ray is glued to the x-axis, and then your terminal ray is something that you move it. Either you go in clockwise direction, counterclockwise direction, depending on what the question is asking you for. So have the same terminal side, they are called coterminal angles. Example, 120 degrees and negative 240 degrees are coterminal angles. So basically, if you look at it, your 120 has this terminal ray and negative 240 also has the same terminal ray. So that's why they both are called coterminal angles. How do you think you can find out? Given any angle, so anytime you're given any angle, if you do that angle, let's call that angle theta. That's what we said we're going to use for angles. Theta plus and minus 360 degrees. That would give you your coterminal angles. Now, how do I decide whether it's going to be plus or minus? Let's say if I had a positive angle, then I subtract 360 and I get my coterminal, which is negative 240. If I had a negative angle, which was negative 240, I'm going to add 360. I got what? 120. So that's how, if you want to go by the formula, that's what it is, because around the circle is complete 360 degrees. Okay, this is the most important concept that we need to know, reference angles. I'm telling you, once you understand this, it'll be so much easier finding angles, values, and you'll see as we go along in the unit that it is of key importance. Associated with every angle drawn in standard position except quadrantal angles. Again, standard position keywords. Standard position is what? When your initial ray is glued to the x-axis. Quadrantal angles are your 0, 90, 180, 270. I'm going to write them down. 0, 90, 180, 270, and 360. I know you've been hearing these for a few words for the first time, but the more we use this language, we will get better with it. There is another angle called reference angle. A reference angle is the acute. Do we remember what acute means? Acute means something that's less than 90 degrees. So I'll read again. A reference angle is the acute angle formed by the terminal side and the x-axis. So let me tell you. Let me finish this. Reference angles may appear in any of the four quadrants. Angles in quadrant 1 are their own reference angles. So what is it saying? Your reference angle, so let's say I'm in the first quadrant. Now I'm not even going to highlight it all the time, but your initial ray is always glued to the x-axis. So you'll not see me overdraw my initial ray. It's there, right? So it's going to be my terminal ray. So reference angle is what it's saying is between the x-axis, that's your x-axis, and your terminal ray. So that would be your reference angle in the first quadrant, which we have it here, right? So if it's, let's say, 60 degrees, my actual angle is also 60 degrees. What happens in the second? It said it's acute, but in the second quadrant, you'll be thinking like, oh, its number is more than 90. How's that working? So again, let's say my angle, my terminal ray is in the second quadrant. Your reference angle here, be very careful. I know. Your reference angle is between the terminal ray and the x-axis, doesn't matter. So this is your reference angle here. Although your actual angle was this, you still picked your reference angle to be the small part because it is the acute angle. It is between the terminal ray and the x-axis. Okay, so I want you to understand that in the third quadrant, I'm going to just refer to the picture. Although your angle is 240, but your reference angle is what? 60, because it is between the x-axis and your terminal ray. So how did you get 60? Isn't this 180? So you basically did 240 minus 180. In the fourth quadrant, this is 360, right? Your actual angle is 315, but I want to find the reference angle of 315, which would be what? 360 minus 315, and that will give you 45. Okay, so always remember, your reference angle will always look like a wing of a butterfly. If I was to draw a triangle here, they will always, let me draw a better picture. It will always look like this. If it's in the first quadrant, it will look like this, fourth, second, so it'll always look like this. It never looks like an hourglass. And as we do more of these questions, you will relate to it, that what do I mean by. So please catch that and cross it out. It'll never look like that because it is between the terminal ray, those are your terminal rays, right? And your x-axis, terminal ray and x-axis. So your theta is here in between. I know it's like a smushed up picture, but that's what it is. Please be very careful. Okay, so the reference angle is the angle formed by the terminal ray and the closest x-axis. For each of the following, draw an arrow pointing at the reference angle. So for the first one, what would it be? It's again, it's an acute angle, so it's going to be the x-axis, that's your closest x-axis, and the terminal ray. So what's the angle in between? That's your reference angle. And what would it be? It'll be 360 minus 290, which is 70 degrees. So again, you should always, for your reference angle, you can never get a number greater than 90 or greater than 90, and it's always positive, so be very careful. Okay, then here, what's your reference angle? It is between the x-axis and the terminal ray, so it is this part. How do I get this number? Remember, the closest number, it is 220 minus 180, which is 40 degrees. So your reference angle, I'm going to write that down. Reference angle is 40 degrees. Here, your reference angle was 70 degrees, right? And that's the work. That's why I want to show it, so that when you go home and you're doing these things on your own, you know what's going on. It's 220 minus 180. Okay, so I want you to try these two and see if you get the same answers as me. So this would be what? 20 degrees, right? Remember to put your degrees up there. Don't write it like this. It looks like 200, so please don't do that. Write your 20 nicely and your degrees like on top, smaller than your 0. Don't make your degree bigger than your 0. Okay, and this would be what? Reference angle is always positive, so this is what? 20 degrees also. So finish up the remaining questions, guys. And if you have any questions, please reach out to your teachers.